Hi, this is Kingfish, and I'm building a low-click action roguelite RTS without a single line of code. And I'd like to show you how I'm doing that in a tutorial series showing you and introducing you to my main tool, which is visual scripting. If you're like me and you've got a great idea for a video game, but you don't have the technical skills to see it out, I think that you can still make meaningful contributions to at least learn how to use Unity to get a step in the right direction, and I'd love to be able to help you out. In service to that goal, we're going to be talking about player movement, and specifically how I accomplished player movement with my 2D top-down / isometric style of The Waking of Haven. Here is a sneak preview of what it will look like if everything works smoothly. Now, this is the first video in a series, so please let me know if this was helpful at all and what you'd like to hear next. As always, subscribing would mean a lot. So while we're talking about movement, we could be talking actually about a few different things. So moving objects in the game like projectiles or bullets, moving the player, or moving AI agents on a nav mesh. These are all worthy topics, but we're going to be focusing on number 2 today, player movement. So the first thing to do is to check in on the input system, which should be connected to the player object. Now, I can't teach you how this works because it's not specific to visual scripting, and quite frankly, other tutorials are so much better at this than I could ever be. My focus right now is hooking up the input system to visual scripting, so if this is unfamiliar to you, I recommend first pausing this video and checking out a few of the other amazing resources at your disposal with regard to the input system. So within the input system, or the input manager, you'll need to set up both mouse and keyboard controls as well as controller. In a nutshell, WASD should map to left, up, back, right, and the controller's left stick should be used to control movement. Now, you can change this however you want or however best meets your goals, but this is what kind of makes sense to me. Both of these capture user input as a vector2 variable. Now, this sounds really fancy, and it's fancier than it should be. I don't really know why, but what this really means is just capturing an X and a Y value into a single variable, which represents how far up and down or left and right you want to go. So for example, if you move the thumbstick up and to the right, which is northeast, the value should be something like 1, 1. Straight down, or S, is 0, -1. So once again, feel free to choose buttons that make sense to you. I've just used W, A, S, and D, and the left controller on, or left thumbstick on controller. Now, as a bonus, I've also added a sprint button, which you press down when you want to sprint and release when you want to stop sprinting. This will come into play in a couple minutes. Now, let's also talk about the different strategies of how to move things with visual scripting or with instructions in code. To my knowledge, you could use nodes or instructions like set velocity, add force, or move towards combined with a set position node. For this demo, we're going to use the set velocity node, which will require a physics system. So make sure to add a rigid body to the player object. Okay, to start off with, this graph is comprised of 3 basic building blocks and a input event. So the input event in question here is the onInput system event vector2. Now that's a mouthful, and we'll unpack that in a moment. But this kickstarts the set of logic that then results in 3 things happening in sequence. First of all, we move the player with the rigid body 2D set velocity node. We then set the player's look direction. And then we animate the player with the animator set bool node. Going back to the input and the event, what the onInput system event vector2 node really is communicating is listening for or waiting for a certain input event to happen and then initiating a set of logic. In this case, it's waiting for you to hold down the movement input action. The way that we would arrive at or search for and find this type of a node is by right-clicking on the graph, clicking on events, looking for the input menu category, and then here we'll see 3 little kind of lightning bolts: onInput system event button, float, and vector2. In this case, we want vector2 because the movement input is a vector2 of the vector2 type. I don't know how to say that. But for other things, like if you want to cast a spell or an ability or jump, that would probably be mapped to a button. But in this case, we want the vector2. Now, within this node, you'll notice that there are inputs on the left and outputs on the right along the edge. The inputs here are fortunately easy. Because the script machine is on the same object as the player input component, that top input, which you can see is a white circle with a blue lightning bolt, that knows by having a default value of this, it knows that the input system that it should be listening to is the same input or player input that is on this object. So we don't have to select any value here. For the input action, we simply need to select the movement action from the dropdown, which is derived from the player inputs we've defined on that player input actions mapping. Now, for the purposes of my game, I have logic here, which you don't need at all, which determines whether or not the speed is greater than 0 before proceeding with any logic. So for example, if the unit is stunned or something like that, there's no point in calculating any additional logic because they can't go anywhere in the first place. Go ahead and disregard this for now. Next, we have a sequence. Now the sequence will take us to the movement, the look direction, and the animation step by step. This is just a way, at least for me, to organize my code, make it look at least a little bit more readable, and to help parse out what different parts of the code are responsible for. So to start off with, let's go ahead and unpack what's going on with the player movement. Now, for the purposes of playing around in a demo, feel free to skip some of this, but in my use case, I need speed. I need to be able to control the player's movement based on speed. And in this case, speed is derived from a variable stored within this graph called speed. And I'm multiplying that speed by the values, the x and y values of the vector 2 that we're getting from the movement. So once again, the vector 2 is just storing roughly what directions are coming in. So if I were on the gamepad or a controller and I was moving the left thumbstick, let's say up and to the left, that would result in values of, I guess that would be -1 for x and 1 for y. And we're going to multiply both of those by the speed, and then a sprint modifier, which again you can disregard for now because it pertains just to my use case where I want my player to sprint or be able to sprint. And that will ultimately result in a x value and a y value modified by the speed and sprint modifiers, which ultimately can be passed into a rigid-bodied 2D set velocity node. This node does all of the action, and everything else is responsible for calculating the value that we want to pass in here. So what this should do in theory is take into account whether or not my player's slow or fast, and whether or not they are sprinting before determining what velocity the player should move. Next up, let's go ahead and talk about look direction. Now, depending on the game that you want to make, if it's top-down or a side-scroller, you may or may not need this. But for me, I'm pulling off kind of a weird, almost like side-scroller, isometric, top-down blend that requires the player to look one direction or the other. Every character is almost at a 3/4 angle toward the camera. And so here we have a couple options that I implement inconsistently. So I use both the flip X node as well as transform local scale nodes. And there's a few reasons for this, but in a nutshell, you can go ahead and disregard the sprite mask and the local scale part of the strategy. I have to implement special logic and special architecture to support shadows on top of my players. So for example, if a player or a unit passes under a tree with a modeled shadow, I have special logic that accounts for making that look special using something called a sprite mask. That's not important to this demo, so let's go ahead and just focus on the flip X node for the sprite renderer. So what I do here is as my second sequence, I look to see if the X value of the vector 2 output, of my movement, the left and right part of the vector 2 is greater than 0. And if that value is greater than 0, then I flip my X coordinate to essentially be -1. I'd say coordinate, I'm sorry. I flip my X scale value to be -1. It flips the sprite horizontally. And of course, if the value is less than 0, then I set it to false, and I flip it back. All right, let's go ahead and move on to animation. So once again, I don't have the opportunity to show you all there is to know about the animation system, but instead, we can just introduce you to how it works in relation to visual scripting. So if you're unfamiliar with the animation system, I highly recommend going out and seeking out additional tutorials from people who are much more skilled at explaining you to the nuances of how that works. My goal here is just to show you how it interfaces with visual scripting. So we have a node here for the animator set bool, and what we can essentially do is we can set the walking variable, or the walking Boolean variable, in the animator controller to true, and then wait 0.1 seconds, and then set it to false. Now you'll notice two things here. One is, why are we waiting 1.1 seconds? And then why do we have this get variable sprite object acting as an input into the animator node? Let's start with that second question first. So why are we inputting the sprite object into the animator node? The reason for that is that in my use case, I actually have the animator component on a child object that I call the sprite object. And that sprite object carries the sprite for the player. That helps me separate the logic of where the player is positioned from where the player visually is. So I have my sprite object in a separate child object of the player object, and for that reason I need to pass in a link to the object that carries the sprite with the animator component into the animator. Now importantly, the light bulb that should be going on for you, I hope, is that this allows you to control the variables, control the components, and affect objects outside of the current object that the script machine is actually currently on. So the second question is, why is there this timer that waits 0.1 seconds before triggering, setting the walking variable in the animator to false? The reason for this is actually because I want the player to stop walking when you let go of the button. Now I could accomplish this by creating a system event that looks for on release, but instead the way that I chose to implement this for my use case is to wait until 1.1 seconds after the on hold movement has stopped. You see, the way that this works in reality is that by selecting on hold on the input node, I've set this up in such a way that every frame that I hold down the movement button will be initiating this series of logic. Every frame will be restarting this timer. And so because frames don't take 0.1 seconds to complete, we'll effectively be starting the same timer every frame until the moment I let go, after which the timer will be allowed to complete, and then we'll send a message to my animator to effectively stop walking. It's probably not the most elegant solution, but it does work. And if it looks stupid, but it works, it ain't stupid. All right, and as a bonus, I wanted to show you how I implemented Sprint. This is very, very straightforward and a little bit similar. So here I have the on hold and on released input system events for the Sprint button. So when I press down on Sprint, in this case shift or I believe the left trigger, I will set a sprinting variable in my graph to true. I will set a variable called sprint modifier to either 1.5 or 1. And then I will sometimes create a visual effect that I call exertion, which is really just kind of like a couple beads of sweat, kind of anime style. The idea is that when I press sprint, the sprint buttons, this will change the variables that I then use later down here to move the player. So when I press sprint, the sprint modifier will shoot to 1.5, which is a direct input into the calculation of my rigid body 2D set velocity node. Okay, well, I think that's about all for this tutorial. If you found it helpful, I would appreciate if you left a comment and a like. And then, of course, if you're looking for, you know, a tutorial on how to do something else specific, I'd love to take your feedback and try to put something together. This is intended to be a series, so we'll see what I come up with next. Also, if you're interested in the Waking of Haven, I have been hard at work putting together a demo that I'd like to share, possibly within the next month, possibly within the next 3 weeks, all depending on my real IRL schedule. Anyway, I thank you for checking this out. I hope you have a wonderful day and take care out there.